Part B says that a stone is thrown upwards. After 3 seconds, its height from the ground is given by, that is our point of interest, that the height of a stone that was thrown upwards is given by 10 plus 20t minus 15t squared. This is the height of the stone from the ground at any time t seconds. Okay, let's see what the question says. The question says find its height, velocity and acceleration at time 2 seconds, 3 and then 5 out of 3. What does it mean here? It means that 1, we need to find the height of this stone at 2 seconds, the height at 3 seconds, the height at 5 out of 3 seconds. And then we also need to find the velocity at the first time, this second time, and this third time. The same applies to acceleration. Find at the time 2, 3, and 5 out of 3. So to make our work more organized, let me get the height first at all the given times. That means I'll get the height at 2, 3, and 5 out of 3. So for Roman 1 of height is when the time is 2 seconds. So we come and use the expression for the height at any time. We substitute for that time and get the height at that given time. Therefore, our height becomes 10 plus 20 times time, because there is t here. T is 2 minus 15 times 2 squared. Our t is 2 here. Then we simplify that. This is like 60 negative 30, because we shall have 10 plus 20 times 2 minus 15 times 2 squared. Negative 10, please. Always use a calculator. I'm getting negative 10 meters. Confirm that. 2 squared times negative 15 plus 10 plus 20 times 2. I'm getting negative 10. So the height of this particle, which is a stone, at the time 2 seconds is 10 meters. That is the height. Okay? What does it mean when the height is negative? When the height is negative, it means that the particle has fallen below the point of projection. Assuming this was our point of projection, which is our ground. If you throw the particle, it will go. There are chances that it will come and then it falls below the point of projection. So when you get a negative height, it means that the particle has fallen below the point of projection. Yes, but that is not our focus. Now, let us go to Roman 2, but still under height. That when time is 3 seconds. When the time is 3 seconds, what is the height? So we say, therefore, our height here becomes, substitute for 3, 10 plus 20 times 3 minus 15 times 3 and squared. So 10 plus 60 minus 15 times 9. Negative 65. Negative 65 meters. So if the time is 3 seconds, then the displacement or the height of the particle is negative 65. Confirm your answer before you leave it. Yes, negative 65. That means if the time increases, for example, from 2 to 3, this particle keeps on falling again further below. Okay? That's why the displacement is increasing downwards because of the sign. But that is not your task to analyze. but the displacement can be negative. Okay, displacement can be negative. What cannot be negative is the distance or the length, but the displacement can be negative. We shall look at that when we are looking at vectors. Now, part 3 says when t equals to 5 out of 3 seconds, what is the height? So our h here becomes, we substitute for t in the expression for the height at any time. That is 10 plus 20 times our t, 5 out of 3 minus 15 times t, 5 out of 3 by the squared. Then we press the calculator and get that value of h. 20 times 5 divided by 3 plus 10 minus 15 times 5 squared divided by 3 squared. Then we press again, 10 plus 20 times 5 divided by 3 minus 15 times 5 squared divided by 3 squared. I'm getting 1, or I'm getting 5 out of 3 meters. So this is the height of the particle when the time is 5 out of 3 seconds. Or you can write it in decimal, or can convert it to decimal, which is 1.6667 meters, and we leave that. So we have done the calculation for height at all the given times. Now let us go to velocity. Now we need to find the velocity when the time is 2, 3, and when it is 5 out of 3. But what is velocity? Velocity is the rate of change of displacement. Our displacement in this case is height. So velocity is the rate of change of height, dh dt. And it means that we need to find dh dt. Now we have h here. Dh dt is simply by differentiating the given function of the height. So when we differentiate 10, which is a constant, we get 0, plus when we differentiate 20t, it gives us 20, and then minus when we differentiate 15t squared, it gives us 30t. So on simplifying this, it gives us 20 minus 30t. This is the expression for the velocity at any time t, that is the rate of change of height, which is the definition of velocity. Now, what is the velocity when the time is 2 seconds? So when the time is 2 seconds, we use the expression for velocity at any time t. Therefore, we shall have all v now becomes 20 minus 30 times t, which is 2. When you press the calculator, negative 14 is 20 minus 30 times 2, negative 14 meters per square second. So the velocity when the time is 2 seconds is negative 40. What does it mean when the velocity is negative? It means that the particle is moving in the opposite direction to the initial direction. It means that it is moving backwards. Now, let's go to Roman 2. When the time is 3 seconds, what is V becomes, to substitute for time as 3 seconds using the same expression at any time, that is 20 minus 30 t, our t now is 3. And then you press the calculator. This is negative 70 meters per second. 20 minus 30 times 3, yes, it is negative 70. What does it mean when the velocity is negative? It is moving in the opposite direction. But with time, the speed keeps on increasing in the opposite direction. That's why the speed here is smaller than here. The sign just shows the direction. Now, lastly, for velocity, what is the velocity when the time is 5 out of 3 seconds? We simply substitute using the same expression that our v now becomes 20 minus 30 times 5 out of 3. That is our time. So 30 times 50 times 5 divided by 3, 20 minus answer, negative 30. I am getting negative 30 meters per second. This is the velocity when the time is 5 out of 3. Can you confirm? 20 minus 30 times 5 divided by 3, negative 30. So those are the values for the velocity at the given times. And lastly, the acceleration. By definition, what is acceleration? Acceleration is the rate of change of velocity, that is the VDT. That means if we have here the expression for velocity at any time t, we can use this expression to get the rate of change of velocity. So let us differentiate the velocity. It gives us 0 minus 30, right? If we differentiate this, and therefore that gives us negative 30. So acceleration is negative 30 at any time t. Acceleration is negative 30. But now, what if our time is 2? When the time is 2 seconds, acceleration, if you look here, it is independent of time. There is no time on it. That means the acceleration is negative 30 regardless of what the time is. So here we shall have negative 30 meters per square second, and that is the answer when the time is 2 seconds. And the same thing applies. What if the time is 3 seconds? Still the acceleration is independent of time. So still our acceleration will still be negative 30 meters per square second. And then finally, Roman 3. What if our time is 5 out of 3 seconds? Still the acceleration is independent of time. So our A will still be negative 30 meters per square second. What does it mean when the acceleration is negative? It means that the body is retarding. Okay, it is retarding. It is slowing down. Okay, negative acceleration is called retardation. Negative acceleration is called negative acceleration is called deceleration or retardation, and we'll learn more about that when we are looking at linear motion in physics. So this is the end of the application of differentiation to kinematics, that is calculating velocity and acceleration. And we have come to the end of differentiation. This is the end of differentiation. Where can I write it? The end. And put it here. Up next, we shall look at integration. So in case you have questions or concerns, please reach out to us and our team will be able to guide you through every step of the way. Thank you so much.